cybersecurity has now taken the center stage. It's one of the top deterrents of IoT adoption, according to various market research data. The main value proposition of industrial IoT is about collecting data from the edge devices, from the industrial assets, and then gaining insights and visualization. Now, to achieve that, now we have the edge computing layer added, and then also the cloud, and the cloud both on-prem and public cloud environments added to the architecture. Now, what that does is it introduces traffic in the north-south direction, and what that means is a big change, because traditionally industrial sites had been segmented away from the IT infrastructure. Now, not only we have the connectivity between IT and OT, we are also seeing traffic actually traversing through the enterprise IT domain, and which could also be multiple domains, and then also external networks. So that introduces threats which are typical to IT networks. So these are new threats to the OT environment. One other change that introduced by industrial IoT is that we are seeing a shift from traditional proprietary OT protocols to open standards. And now open protocols exposes even in the lateral connectivity. So laterally in the east-west traffic also, now we have protocols and devices using standardized stacks, so which are really visible to the adversaries and exposes the OT environment to unprecedented levels of threats. We're talking about control networks, which are very time-sensitive and deterministic networks. And downtime is not something that we can accept. So the traditional approach to vulnerability scanning and then patching becomes really difficult. And then we are also talking about wireless connectivity. Because of the geographical spread of a typical industrial use case, we can think of a simple analogy of a self-driving car, which many of us might drive in the near future. So what happens there is that we cannot apply a patch when the car is running on a freeway, right? An exploit to stop the car which is driving at 60 miles per hour to zero in no time. So these will cause great hazards. And these operational dynamics are very much applicable across the board. And then unlike IT, where we are mostly concerned about data integrity and data and identity protection, here the focus is more on availability and reliability. So in OT networks, we are concerned more about reliability, and the impact of an attack can cost lives. It can have safety and environmental implications. Traditionally, and even now, the emphasis of security in the OT side of the house is always reliability and availability. Downtimes, we cannot just reset something for no reason as easily as we can do in IT. Things boil down to what we call trustworthiness from the tradition. Unlike information security, this is more about trustworthiness. Now the hacking has become a very lucrative industry. Many nation state actors and big organizations are funding this. Industrial espionage is more prevalent than what it used to be. So what that really means is that we have well-funded, highly sophisticated, and highly talented threat actors behind this, which really makes the threat vectors and the kind of the threat dynamics much more serious than, much more severe than what it used to be. One of the most compelling questions is how do we approach this, how we solve this IIoT security puzzle. And that very well centers around ICS security too. Now, there's no short answer to this. There's no shortcut to this. There's no silver bullet. I think we all realize that. And then, but if we apply a few principles that at least guides us implementing the right security measures. So first is really we have to understand that the IT centric security is no longer applicable. The security measures that works in the IT settings are not cannot be as is applied on the OT side. Some industries have done that. In the pharma industry, we have some companies which have applied IT-centric security, but they could not prevent breaches. They were, they were victims of security attacks. So for OT, the security approach has to be different from IT. And if we take the overall, the overarching IIoT security problem, which really involves both IT and OT, we have to see that there has to be certain controls which are equally applicable, and we cannot any longer live with the reactive approach of, let's say, applying fixes, coming up with a security patch after the vulnerability has been exposed, 0 day, and so forth. And then what we also cannot do, for example, is coming up with solutions, constantly chasing the solutions and coming up. So the reactive, because that is that may be too late to save a critical infrastructure or something similar. So the central mantra, this very guiding mantra for this IIoT security puzzle is secure every stage and every layer. And what really that means, every stage? So I think we are familiar with secure development lifecycle, the SDLC. I tend to call it SDDLC because secure development and deployment lifecycle. I think we have to look at the entire lifecycle, the various stages, starting from business case development, secure coding and requirements traceability. And because secure coding is one area that is most important, applying security by design can prevent a lot of vulnerabilities that are exposed in the field. So that's a key phase which we have to consider. And then securing the supply chain. There are definite steps to do that, and then we have to explore what those are, because the supply chain has to be secure. How do we apply the fixes, and how do we upgrade regular upgrades? How do we securely upgrade firmware upgrades and software upgrades? And then in the deployment phase, how we really monitor and ensure that the deployment is secure at all times. So that's the various stages till a device is retired. We have to be monitoring and managing the various aspects, upgrades, and so forth. And then the other part is every layer. Now, what does every layer really mean? Is that we can maybe decompose an entire IoT architecture into 4 or 5 layers. For example, the endpoints, the devices, and the device, and every entity in the deployment, the machines, has to be secure. IEC 62443 is very provides some guidance on that, and how to build architectures even to secure the less secure legacy and resource constrained IoT systems, and then securing the network, because we are increasingly relying on wireless and OTA, basically wireless for connectivity. So we have to find securing the connectivity layer, the routing and the switching, and also comes under that. And how do we design the connectivity? Because here we may have multiple domains, multiple verticals. A power generation, a power grid may be actually connected to a water treatment facility, and so forth. So we have to think in those terms too about secure connectivity, securing the connectivity layer, and then the application layer and of course cloud security. So at every layer we have to find out what are the standards applicable, and what kind of controls are needed. And across all these layers, something I must mention is that compliance. Now most of the verticals, most of the industrial organizations come under some form or the other of regulations, and it is a very it's very common and very common practice to think that compliance is enough for security, but that's unfortunately is not true. So in addition to compliance, compliance is something we cannot get away with, and that's really a good practice. But in addition to compliance, it's important to at least do risk management, threat modeling, and to find out what we need to do at every stage and at every layer, and how we can be proactive. Having a good visibility of the assets spread across your deployment, that is important. Asset monitoring, and along with that event monitoring also, as far as possible, monitoring the events. And there are now AI and machine learning for to managing the that scale of event, what how extensive event monitoring may get. But having a good event monitoring is very helpful to detect threats early, because in a proactive approach, the whole thing is about preventing threats, detecting threats early, and having a solid incident response system, incident response management system in place. It is a problem for most organizations to really get the security budget and to really implement security. Just managing the vendor and technology complexities is one part of the problem. The other is you may not even have the in-house resources, and the other problem is just the funding of it, because security is costly. The solutions cost. So and I may not even be able to have enough budget for the security. So that is resulting in two trends. Some organizations are moving forward, adopting IoT, moving forward without securing them. If they're just meeting the compliance criteria and just moving forward, that we are seeing that on one side of the spectrum, and the others are just standing on the fence and not even adopting IoT just because they cannot secure it. So there is a middle point to this. What we can do is we can implement security just right for my use case. So and from a business. So not every IoT use case require the same amount of are exposed to the same levels of risk, and as such do not need the same amount of security investment. What we have to do is what is called right sizing security. What that really means is that I do a risk assessment and find out what are the various risks at the various stages and the various layers that we earlier talked about, and then design security according to that. One other thing I must mention in this context is a security maturity model. So we can never future-proof security. Security attacks, the threat scape is constantly evolving, and it's not just never possible to really future-proof. So what we have to do is that we have to decide a baseline security, which is kind of our starting point, and depending on our risk tolerance, and then we build on this. Then when we have problems like this, the huge deficit also compels us. The silver lining is that it also compels us to think in innovative terms. So let's see what happened in the cloud security industry. There we are seeing this new thing about shift left. So basically shift security left, that is moving it from runtime to the build time. And that's the direction, that's probably the most practical direction in which IIoT security also has to move, and also expanding the security envelope from just focused security teams to the people who are actually the engineers, essentially the engineers and other operators and other folks who are involved in building the systems.